Hello students, welcome to physics class, and in this particular video we are discussing about this fourth chapter of first piece of physics. There is a motion in a plane. In a last sessions we are discussing about motion of a body in a straight line, and it is continued that the study of motion on a plane. And before we are going to study about this motion in a plane, we have to know about these vectors. And let us see what is a scalar and vectors first, and then how we can use these vectors in order to study this motion in a plane. Let us see. Say in a physical quantities we have two types, that is a scalars and vectors. A physical quantity which have magnitude but no directions, they are called scalars. Scalars ಎಂದರೆ ಏನು ಅಂತ ನೀವು ಆಲ್ರೆಡಿ ಇನ್ ಎ ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್ ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವೆ. ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ಗೆ ಡೈರೆಕ್ಷನ್ ಇರುವುದಿಲ್ಲ, ಓನ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮಾತ್ರ ಇರುತ್ತೆ, ಅಂಥದನ್ನು ಸ್ಕೇಲಾರ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಡಿಸ್ಟೆನ್ಸ್, ಸ್ಪೀಡ್, ಮಾಸ್, temperature, they have only magnitude, no directions. Similarly, those physical quantities having both magnitude and directions, they are called vectors. ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಗೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ಸ್ ಎರಡೂ ಇರುತ್ತೆ ಅಂತ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅನ್ನು ವೆಕ್ಟರ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಕ್ಯಾನ್ ಸಿ ಇನ್ ಅ ಪಿಕ್ಚರ್ಸ್ ದ ಟೈಮ್, ಮಾಸ್, ಟೆಂಪರೇಚರ್, ದೇ ಆರ್ ಓನ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್. ಅದಕ್ಕೆ ಯಾವ direction ಅಲ್ಲಿ ಇದೆ, it is not independent of directions, and such a physical quantities are called scalars. ಅದೇ ಕೆಳಗಡೆ ನೀವು ಪಿಕ್ಚರ್ಸ್ ನೋಡೋದು ಗ್ರಾವಿಟೇಷನ್ ಫೋರ್ಸ್, a man is freely falling, then he was attracted in a particular directions. ಅಂತ physical quantities, it has a gravitation force, so is acting in a particular direction, they are called vectors. Similarly, you can observe this magnetic field. Also, the magnetic field is either attracted or repelled in a particular direction, they are called vectors. Students, this is clear that the physical quantity having only magnitudes, no direction, scalars. Physical quantities having both magnitude and direction, vectors. And let's see in these vectors how we can represent these vectors, and analytical as well as graphically see. Vector is denoted by letters with an arrow over it. ಈ ವೆಕ್ಟರ್ಸ್ ಅನ್ನು ಬರಿಬೇಕಾದ್ರೆ ಯಾವುದು ಒಂದು ಲೆಟರ್ ನ ಮೇಲ್ಗಡೆ ನಾವು ಆರೋ ಹಾಕ್ತೇವೆ. ದಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಇಸ್ ಎ ವೆಕ್ಟರ್. ಆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ವೆಕ್ಟರ್ಸ್, ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನಿದೆ ಅದನ್ನು ಯಾವುದು ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಆರ್ ಸಿಂಪ್ಲಿ ಎ ಯು ಆರ್ ರೈಟಿಂಗ್ ಇಸ್ ಆಲ್ವೇಸ್ ಎ ಪಾಸಿಟಿವ್ ಕ್ವಾಂಟಿಟಿ, and arrow is indicates its direction. For example, the force F is acting on a body, then we are writing F with the arrow mark. That indicates that quantity is a vector. And 10 Newton, where 10 is a magnitude, the 10 is called magnitude, Newton is a unit. This is a way of writing vectors analytically. Then when you are drawing figures, how graphically represent this vector? A vector is represented by a straight line with a arrow over it. ಅದಕ್ಕೊಂದು arrow ಹಾಕಬೇಕು, and that is a straight line with the arrow is represent a vectors, and the length of this particular line, ಆ ಲೈನ್ ನ ಉದ್ದ ಎಷ್ಟಿದೆ ಅದು ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ದೆನ್ ಆರೋ ಇಸ್ ಇಂಡಿಕೇಟ್ಸ್, ಅದರ ಎದುರಿರುವಂತ ಆರೋ ಇದೆ, ಬಾಣದ ಗುರುತಿದೆ, ಅದು ಡೈರೆಕ್ಷನ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ದಟ್ ಈಸ್ ಎ ವೇ ಆಫ್ ವೆನ್ ಯು ಡ್ರಾಯಿಂಗ್ ಎ ಡಯಾಗ್ರಾಮ್ಸ್ we are representing these vectors in these manners. Similarly, now we are discussing about different types of vectors. Vector ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಟೈಪ್ ವಿಧಗಳಿವೆ. In the examination point of view, the one mark question is asking what is a null vector, what is a zero vector, unit vector, etc. Let us see what are the types of vectors. First, they are given zero or null vector. A vector having a zero magnitude, ಒಂದು ವೆಕ್ಟರ್ಗೆ ಝೀರೋ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇದೆ, ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಝೀರೋ ಇದೆ, is called zero or null vector. What is a zero vector? Vector having a zero magnitude are called zero vector or null vector. Similarly, unit vector. What is a unit vector? A vector whose magnitude is unity, ಒಂದು, ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಒಂದಾಗಿದ್ರೆ, ಯೂನಿಟಿ ಆಗಿದ್ರೆ, then is called unit vectors. Like in the special notations we are using, there is a with a cap, a cap, A ಗೆ ಒಂದು ಕ್ಯಾಪ್ ಇಟ್ಟರೆ that is indicates that is the unit vector of a. But that in a Cartesian coordinates ಅಂದರೆ x y z axis ಅಲ್ಲಿ usually when you are representing any position vector we are using unit vectors as a I unit vectors. ಅದು unit vector along x axis, j unit vector is a unit vector along y axis, k unit vector is a unit vector along z axis, and these are these unit vectors. And next, position vectors. A vector which gives the position of a particles with reference to origin of a coordinate system is called position vectors. ಒಂದು vectors, it is giving position of a particle, ಆ ಪಾರ್ಟಿಕಲ್ ಎಲ್ಲಿದೆ, ಯಾವ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ಕೊಡುವಂತ ಒಂದು vectors. It is reference with the origin of a coordinate system. They are called position vector. ನೀವು ಫಿಗರ್ ನೋಡಬಹುದು, and that is represent what is the position of these particular vectors in with respect to these coordinate systems. And then negative vector. Negative vector ಅಂದರೆ ಏನು? A vector equal in magnitude but opposite in direction of given vector. Okay? A vector, A vector is given vector ಆದರೆ ಅಲ್ಲಿ ಇನ್ನೊಂದು ವೆಕ್ಟರ್ ನೀವು ನೋಡಬಹುದು minus A vector that is a equal in magnitude as that of A but it's a opposite directions. Okay? And such a vectors are called negative of a given vector. ಅದನ್ನು negative of a given vector ಅಂತ ಹೇಳ್ತೇವೆ. Okay? Next, equal vectors. If a two vectors are equal in magnitude as well as same direction, they are acting along the same direction. Figure ಇದ್ದಾಗೆ ಎರಡು ವೆಕ್ಟರ್ಸ್ ಕೂಡ ಒಂದೇ ಲೆಂತ್ ಅಲ್ಲಿ ಇದೆ, ಮತ್ತೆ ಈಕ್ವಲ್ ಇನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮತ್ತೆ ಒಂದೇ ದಿಕ್ಕಿನಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ದೇ ಆರ್ ಈಕ್ವಲ್ ಇನ್ ಸೇಮ್ ಇನ್ ಡೈರೆಕ್ಷನ್. such a vectors are called equal vectors. Next, parallel vectors. The vectors whose line of actions are parallel. ನೋಡಬಹುದು ಸಮಾಂತರವಾಗಿ ಎರಡು ವೆಕ್ಟರ್ಸ್ ಇದೆ, they are acting along the same directions and then action is in parallel to each other, and such a vectors are called parallel vectors. Concurrent vectors. The vectors having a same initial point, ಅದರ origin starting point same ಆಗಿದ್ರೆ then such a vectors are called concurrent vectors. Then vectors which is having a same plane, they are called coplanar vectors. Coplanar vectors ಅಂದರೆ vector acting on the same plane, ಒಂದೇ ಸಮತಲದಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿರುವಂತ ವೆಕ್ಟರ್ಸ್ ಅನ್ನು coplanar vectors ಅಂತ ಹೇಳ್ತೀವಿ. And these are the different types of vector so far discussed. Next we see how to add vectors, addition of vectors. ಈ vectors ಗಳನ್ನು ಯಾವ ರೀತಿ ಆಡ್ ಮಾಡಬಹುದು, ಯಾಕಂದ್ರೆ in a study of this motion in a plane we will come across vector quantities. vector quantities ಗಳು ಬರುತ್ತೆ, ಆ ಎರಡು vectors quantities ಗಳು ಬಂದ್ರೆ ಅದನ್ನು ಯಾವ ರೀತಿ ಕೂಡಿಸುವುದು, ಆಡ್ ಮಾಡೋದು. The two or more vectors can be added by using a law of additions. ಅಲ್ಲೊಂದು vector law of addition ಅಂತ ಇದೆ. Using this law of vector addition we can add any two or more than two vectors. Let us see what are these laws of vector additions. Okay? Law of triangle and law of triangle of vector addition and law of parallelogram of vector addition. There will be two laws are mainly we are using, law of triangle of vector addition and law of parallelogram of vector addition. Let us see in detail about these laws of vector additions. First, law of triangle of vector addition. The statement is given that it is a states that if two vectors can be represented in magnitude and direction by two sides of a triangle taken in the same order, then the resultant is represented completely by the third side of a triangle taken in opposite order. Okay, you can see in the pictures. Suppose I have a two vectors which is acting at a point in such a way that the two vectors are like two sides of a triangle taken in the same order. A and B are two vectors. They are like a two sides of a triangle ABC. Then the third side of a triangle, okay, which is taken in opposite order from A to B. Okay, what is the third side of a triangle, and that is represent what is a vector sum of these vectors, that is A vector plus B vector. This is a law of triangle of vector addition. Similarly, law of parallelogram of vector addition. The statement is says that if a two vectors are acting at a point are represented in magnitude and direction by two adjacent sides of a parallelograms. Okay? It is acting like as in figure, two sides of a parallelograms then they have a same origin, but they are acting in a certain angles with each other. Then how to represent its sum or resultant? Then the resultant is represented both in magnitude and direction by diagonal of these completed parallelograms. The diagonal, the diagonal of a completed parallelogram drawn from this point. Let's see here in a pictures. Suppose A and B are two vectors act like two adjacent sides of a parallelograms. Then I'll complete these parallelograms and such a way that I'll draw one diagonals. Okay? And the diagonal is represent what is the resultant of these two vectors. That is the R vector is equal to A vector plus B vector. Let us see, we will give the expression for magnitude and direction of resultant of two vectors acting at a point. This is important. The statements are sometimes asking for 2 mark questions, and this is a derivation they are asking for 5 mark questions. Derive expression for magnitude and direction of resultant of two vectors acting at a point. Then you can observe that A and B are two vectors represent these two adjacent sides of a parallelogram OACB. Okay? By that, these two vectors are inclined with an angle theta as shown in figure. The resultant vector R is represented both in magnitude and direction by the diagonal OC of a parallelogram OACB, okay? As in figure. Let us derive the expression for this magnitude of this particular resultant vectors. For that we have to extend this line OA till this B, and also I will draw a perpendicular to OA extended lines from C. That CD is a perpendicular drawn for a line OD. Then you will get one right angles. Then this, let us take this angle is theta. Then we have to derive expression for magnitude of the resultant by as in figure. Okay. Let us take this right angle triangle ODC, right angle triangle OCD. In this particular right angle triangle, I will use Pythagoras theorem, where that the OC square is equal to OD square plus CD square or DC square. Okay. And this is Pythagoras theorem. The third side OC square is equal to sum of the other two sides OD square plus DC square. Now what is OD? I will rewrite like this: OD and OA plus AD in the bracket. Okay. OD I will write as OA plus AD, where that OA plus AD square plus DC square. And we know that A plus B whole square, that is equal to A square plus B square plus 2AB. I will use this formula, and OA plus AD whole square I will write as OA square plus AD square plus 2 into OA plus AD plus what is the DC square. I will keep as it is. Next, I will use another right angle triangle, that is a ADC. I will use another right angle triangle ADC. In this particular ADC, what is a AC square, that is the third side of a triangle, that is equal to AD square plus DC square. Okay. So that AD square plus DC square is equal to AC square. Then because of that reason, in above equation AD square plus DC square I will replace as a AC square. And also in this particular right angle triangle ADC, I will use trigonometric angle as a cos theta. Cos theta is equal to AD by AC. Then I will rewrite like this: AD is equal to AC cos theta. I will rewrite this equation as a OA square plus 2 into OA into AD I will write as AC cos theta plus AC square. And since in this equations OA is equal to A, OB is equal to AC, that is equal to B, and OC is equal to R. Now I will substitute OA as A in above equations, OB as AC, that is equal to B, OC, that is equal to R. Then above equation become R square is equal to A square plus B square plus 2A into B into cos theta. And this equation I will rewrite like that: R is equal to square root of A square plus B square plus 2AB cos theta. This is represent magnitude of resultant of two vectors. This represent magnitude of resultant of two vectors. Next you will see directions. ಯಾವ directionally resultant ಆಗ್ತದೆ and to know about direction to know about angle of with which this resultant is acting. The direction is calculated based on this angle made by r with the r vector with the a vectors. Now that what is a alpha is the angle made by r vector with the a vector. Then we'll use this particular right angle triangle ODC. In this right angle triangle ODC, tan alpha is equal to the base divided by opposite side. So that the CD divided by OD. As in figure, tan alpha is equal to CD divided by OD. I'll write CD as it is, but OD I'll rewrite like OA plus AD. As in figure, OD is equal to OA plus AD. Then again I'll rewrite this particular equations by using a triangle. A small triangle is there. It's a ABC. It is having angle of theta. Using this triangle ADC, the cos theta is equal to AD divided by AC. In this relation, I'll write AD is equal to AC cos theta. Similarly, sin theta is equal to CD divided by AC. CD divided by AC. Using this relation, CD I'll rewrite as AC. Substitute the both AD as well as CD in above equation, then you'll get AC CD as AC sin theta. Then OA plus what is that? AD I'll write as AC cos theta. Then figure OA is represent a vector A, magnitude of vector A, and OB as well as AC they are equal. They represent magnitude of vector B. Then above equation the tan alpha I will rewrite like that B sin theta divided by A plus B cos theta. Or the direction of resultant alpha we can get based on this relation. Alpha is equal to tan inverse of B sin theta divided by A plus B cos theta. And this is a direction you can get from this particular relations. Another operation is that is subtraction operations. How I can subtract two vectors? The subtraction of vectors can be defined in terms of addition of vectors. Subtraction also we can do using the same rules of addition, but just adding a negative of vector to this vector. That means A minus B is equal to is nothing but A plus minus B. A plus minus of B, that is giving A minus B. Using the simple logic, I'll use a law of triangle for vector additions and I'll find out resultant of A minus B vector. As in figure, I have a vector and I have a B vector. First I'll find out negative of a B vector, means the reversing this direction of B will get a negative of B, then A and minus B will add, then you'll get A minus B. The simple way we can get a resultant of A vector minus B vector. That is the subtraction of a vector using a law of additions. Next, multiplication of vectors. Vectors can be multiplied by a real numbers and vectors can multiply by a scalars and vectors can multiply by vectors. Like that we have a different type of multiplication of vectors will get. If suppose you multiply by real numbers, just the numbers, then what is getting a vector into n, say n into a vector. Only vector is multiplied by a real number n, then its magnitude is become n times increases, but direction is remains unchanged or remains same. Whether directions change agilla, only magnitude is increased n times. Okay? That is a multiplication of a real number. Then multiplication by a scalar. Suppose a vector is multiplied by another scalar quantity, then magnitude of vector is increased m times or s times, then direction is same as it is, remains same. That product is only magnitudes. That we will get a s into a is magnitude. This is a multiplication of vectors by a scalar. Next, vector is multiplied by vectors. When vector is multiplied by vector, we have two type of products. Okay? One is scalar product, another is vector product. That we have a two type of multiplication of vectors by vectors. One is scalar or dot product of two vectors, and another is cross product